Hi, what we are doing, we are examining, that's chapter 5, we are examining the MSI combinational elements. Among those elements, we have seen decoders and we have seen multiplexers. While we are examining these MSI elements, we said we could use these elements for the design of Boolean functions. Also, we said how we could use these elements in computer science. That means decoding of the commands, and also the encoder businesses can be done by encoders. Now we are going to see an application uh, which use decoders and multiplexers in. This is a completely new area where these two elements are being used. This is switching operation. So this video is about the switching operation by using the multiplexers and decoders. And then the other MSI elements are going to be parallelators and comparators. But this video is about this switching operation. So we are going to look at the decoder element from a different angle. So that is the definition of the decoder, which has got an enable input in it, and this is 2 times 4 encoder, and E is the control input, and these are the other inputs. So I'm going to expand this definition relation in this form. As you see it, when enable equal to 0, all the outputs are going to be 0. Here you are. Whatever the x1 and x2 inputs are, when the enable is 0, output is 0. So this line here is represented in this expanded definition relation in here. For enable equal to 1 case, these 4 lines are in here. Okay. So let's look at inside now. What we are going, our angle to find this decoder element is to interchange the function of control input and the normal input. What I mean is this. This is a control input in here. So I'm going to consider it, this control input, as a normal input here. Normal input. And those two was the normal input. But in here I consider those two as control inputs. What happens? This happens. Let's examine it. If you choose the control inputs as 0, 0, it's in red color here. So we're talking about this now. So there are two alternatives, isn't it? Control input is 0, 0, and enable input just one input, normal input. It could be either 0 or 1. So if you look at the M0 output now, when the control input 0, 0, what I am observing at the output M0 is the same as E, isn't it? These red ones. So this E transferred to here, that E value transferred to this for the red one. So M0 is equal to E. If you choose the control input 0, 1, that's the dark blue, and this is another dark blue. For this dark blue, E is equal to 0. For this dark blue, 1 is E is 1. So if you observe not M0, but in this case M1, M1 value is the same as E value here, is also the same as E value here. So M1 becomes E when the control input is 0, 1. When control input is 1, 0, your M2 output is the same as E. That's the green case. If you repeat it for the last one, so M3 output is going to be the same as E. Let's interpret this definition relation in here now. When my control input are 0, 0, this E is transferred to M0. If you choose the control input 0, 1, then this E value is transferred to M1. If you choose the control input 1, 0, then E input is going to be transferred to M2 here. In the last case, if you choose the control input 1, 1, so the E input values are transferred to M3. So that is the switching operation. So you are sending the information to different destinations in here. How we are going to use this information in switching will be examined here now. Here are, there is one mux here and there is one decoder here. And assume that this is Istanbul and this is Ankara. And assume that in Istanbul there are so many people, one of them called Ahmet is this X1 person. And let's say this F is Fatma, that is the another person in Ankara. And we would like to have those pair communicate to each other. So in between Istanbul and Ankara there is a transmission media or transmission media here. You might control a wire here. In communication it is called trunk. So there is a trunk here. I would like to communicate, make those two pairs to communicate between themselves. So that means they are going to share this line, those two people. How they are going to do that is to connect the A line, Ahmed's line, to this terminal of the line. So you're going to do this operation here. And here you're going to connect this trunk, the other end, to Fatma. How I'm going to do it, as you remember the mux element definition relation, if you choose the data select 0, 0, so the first input information is going to be transferred to output of the mux. So in here, I've got this connection. If you look at the other side, data select, so that is the 0 person, that's the first person, second, third, fourth, and that's the fifth person, isn't it? So fifth person, if I choose 1, 0, 1 here, so that means as just we examined before, decoder enable line is going to be connected to this. In the previous one, it was enable 4 to 1 decoder. This one is 1/8 decoder. Just the size has changed, it means these outputs are changed. Anyway, if we selected the data select 101, so this F is going to be connected to this. Or another way of saying it, the information on that trunk, this terminal, is going to be transferred to Fatma line. So what happened is this: by choosing this data select 00 on Istanbul side and 101 in Ankara side, so you are connected Ahmet one of the terminal and Fatma to the other terminal, so they can communicate now. This operation is called switching. Why we need that such an operation? If you don't use any operation like that, for each pair you've got to have a one line to do their communication. But those people, they don't talk to each other at the same time forever. So let's say Ahmed and Fatma communicates for 5 minutes, then they use that line. For the other 5 minutes, you're going to connect the other two, the other pair. For example, in here, Mehmet and Aisha here. So according to Mehmet Ayşe connection, so you're going to choose this data select to do this connection. Then that means you are sharing that line for different place people. That means the sharing operation. What we have done here by this switching, we have managed that. Let's go a bit further. So let's say you are doing the digital communication, not the analog communication. When you do the digital communication, at the same time, you're going to set more bits at a time. Assume that you would like to send 4 bits at any time. So in this case, you've got 4 trunks. 4 trunks, the terminals of these trunks have got muxes, and the other terminals of these mux, you've got decoders. So assume, in order to make it more simpler, assume that in this site you've got two person A and B, and here you've got C and D, 2 persons. So the number of muxes and decoders you're going to use depends on the uh, trunks, the number of trunks that you're going to use. Once you have chosen that, the size of the mux is how we are going to determine. We are going to determine them according to the elements that we are going to the number of persons that they are going to share this trunk with the other end in Ankara, some other people. So to make it simpler, we said there are 2 persons here, so we're going to have a 2 times 1 mux. So one of the inputs of these 4 muxes is related to this person A0, A1, A2, A3. So if I choose the data select here, 0, 0, so that means Ahmet's related 4 bits are going to be transferred to my trunks in the order of A0, A1, A2, A3. So for all these 4 muxes, same data select we have done. So that means for this, the first input is going to transfer to the output. For the second mux, first input transfer to the output, third mux and fourth mux, the A's. So these A0, A1, A2, A3 bits are related with the person Ahmed, A that is. On the other hand, if I am going to communicate, I would like to communicate A and D on the other side, D. So I'm going to choose D here. So I'm going to choose 0, 1 data select here. When you switch select, you might call it. When you select this one, then that means the other terminals of these trunks are going to be connected to D0, D1, D2, and D3 because 0, 1. If you were to choose 0, 0 here, you were going to do this connection to the C's here. In here, right now, it is D connection. So that means you made a connection, 4-bit connection between Ahmed and D, let's say Deria. So they can communicate. They can communicate now digitally. This is a more schematic form of it. So if you transfer it to higher size MSI elements, you can show it like that. So in this show, you can see that I can say that the first end here and the first end here in the B side and the A side, these two are in this represent this mux. This red one and this red one is the second mux here, and this third end, and this third end here represent this mux here. So that means third wire as well. So the last one is this one, isn't it? The last AND gate, the last AND gate here in this group. That means B related group, and that's the mux in it. So, and every mux has got an OR gate, so the order is going to be the same as this, isn't it? So this one, and this one. So there are 4 color here. For each color is represented here by the 2 times 1 mux. Now we can then let me uh, offer you a assignment saying that assume that on this side, let's say anchor side, you've got um, P persons. On this side, you've got K persons, and assume that in here the trunk, the number of bits that you're going to transfer at the same time, let's say 8. Now question is how many muxes are going to be used and size, how many decoders being used and size. So you made a decision. This is a, let's say, a communication problem in order to design a parallel switching. So that's the end of this video then.